GPLHOW2J. Okay, I took a program called Hacker Hoedown and I wanted all the music from it to put in the game. So first thing I had to do is I had to load the program and look at it to see how it was creating the sounds so I could move that over to GPL from XB to GPL. So that's this listing. Okay, in this section right here, this is a hacked version that I created of the routines for it. So it'll automatically look for another program, which is going to be called ST, which is actually a sound table program from a previous sound to GPL from BASIC. So this is a listing for Hacker. Okay, now I'm going to show you the only two lines I added to the program. I added one for open a file, and I added 241, which is going to be to grab variable. This is going to be the sound table program from a previous GPL how-to. And what I did was I turned it into a merge file, but I changed some lines in it. This is the listing, and you'll see lines 10010 through 10040 have been taken out. Those were the input statements you would type in for your call sounds for what generator, duration, frequency, and volume. What I did with the Hacker program is I took all the variables from a call sound and I turned into variables for this program. So the input is going to be this merged program is going to take those variables and turn it into our data statements we'd normally make. And it's pretty simple and easy to understand. And then I typed it down below to explain what's going on. Okay, I ran the program, but I'm not going to show you that because it takes forever to run. But what I did end up with the input, I have to take and I turn it into a DOS text file using TI directory. Then I use this program right here. It takes the file, converted it into a text file for DOS, and put it into Classic 99. And what this program does is you run the program and then you drop in that text file. This converts those multiple data statements, each single data statement for a single generator, into a combined group. I could have done that into the program originally, but I hadn't thought of it at the time until I had my results. So I created this program. I probably should have converted it into one single loop instead of two programs. But this gives you a better example of how it worked and how I pulled it off. So that's why I put it here. Okay, I'm going to speed this up 800% to show you, but that text file being dropped in here makes a lot of racket because it goes beep, 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 beep over and over again. So I just got up and left. It took 10 minutes to run. Probably would have been better if I would have taken this and put it in the original program I showed you from Hacker and combined it with ST, and that would have made a lot more sense. But I just wanted to show you how easy this is to do if you drag and drop a file into this little bitty routine I wrote. It's pretty silly that just three inputs together can do the same thing that a DV80 file that I read. I couldn't read the DV80 file properly from because I hadn't set it up for DOS reading, reading DOS files from TI. So instead what I did was I just drag and dropped. It seemed a lot easier to do at the time. But this creates our text file that we need, which is all the data statements combined into a single data statement for GPL. You can also use these as assembly, or I suppose they're very similar to what you could use in even fourth. So here you go. Okay, this is just to show you the difference between the two data statements that was created by the two programs. Hacker created this one, which are the individual generator lines. Generator 0, 0, 1, and 2. It's only using 3 generators on this sound program. And what I wanted to do is I wanted to show you the difference between the Hacker program output and the output from the LinePut program. You see that the data statements have a 3, 3, 3, and what that means is that it's only 3 bytes for the sound. That's just one generator. So I had to turn this into multiple, which is going to use this 9, which is the sounds combined into one single statement for GPL. You could also use this for assembly, I think, because it uses data and byte statements. I don't think that's any different than assembly. And just wanted to show you what they did and how it works and the results. So that's all this is. All right, now what we have to do is we have to take that file that we've got the multiple data statements for, and we have to set it up for GPL. What we're going to do that is we're going to add this thing at the top, which is called hoedown byte 00. What this does is it tells the interpreter that the next sound is going to have a data statement behind it, which is going to be an address of the sound list to play. So when you look at this at the top, you're going to see that it says byte 00, then it says data muse, and then muse is going to be the listing. Now it'll play this list once. It doesn't play it endlessly. The trouble is it's like a for next loop. You have a for at the top, but you need a next at the bottom. So what we're going to have to do is we're going to put one just like that at the bottom. And the difference between the two of them is going to be that one is going to point to the list, to play the entire list. When you get to the bottom is going to point to the list at the top, and that list is going to point at the list. It sounds a little confusing at first, but once you look at this, what I've done here, you'll see it. Now, I'm just typing this to explain this because at the time I hadn't intended on putting voice in here because, well, I was being lazy. But anyways, here you go. All right, this is the original game we had, and what we're going to do here is we're going to show you the SPOP game that we had from the last GPLHOW2J demo. And what this is all about is I'm just going to show you things that I changed in SPOP to make the game use the sounds, and for different sections of it to respond to the sounds. Now this section right here is I go double store at 83cc at MUSED. What I'm doing is I'm saving the sound list address where we're playing the sound at. And the reason why I'm doing that is because if you start another sound from a sound list, it interrupts the sound list. Now, how do you know where you were in the sound list when you go to start again? Well, if you start playing it from that point on, the interpreter thinks that that's the listing for the length of the sound bytes. And you start getting a list that's like of these weird values, and so it starts playing all kinds of weird noises. So what I did was I used this little section right here to get that address, to save it, to find the start address of that line, and then I added 11 to that address, and I moved past that address. So that's all this listing is just to show you how that works. And then I'm typing here to explain how that went. At the time, I hadn't planned on putting any speech into this demo, so you can either read the typing that I'm doing here, which takes a long time, or you can, listen to me talk, which is not much better. Anyways, how it works is that it does a double store 83cc, which is fixed inside the machine for that address. For the list, it's the address that it's playing a sound at. Now, 83CE is the fixed address for the sound list, and when it says 00, that means it's done with the list. So what I do is I double stored A3CC at MUSED. I double stored MUSED at argument because we're going to take argument and we're going to start using it to calculate where we want to end up at. And then here I'm typing that you need to use the music address for the present address, which I already just told you by voice. Then what we're going to do is we're going to do subtract 11 from that argument. Now the reason why we're subtracting 11 is because each one of the listings is 11 bytes long, like I told you before. And it starts with that 11 bytes with a listing for how many sounds to play, which is going to say 9 because there's 9 in the listing, plus then you have 2 values beyond that. That's 9 is your frequencies that you're going to be playing, and your generators that are used. The other 2 bytes are going to be the 9, which tells you the listing's length, and the byte for the volume. So add those up, that's 11, 9, 10, 11. Anyways, so then the next thing it's going to do is it's going to double check. Now, because 12 is larger than 11, we're going to check for 12. If it's higher than or equal to 12, then obviously we have to subtract 11 from it again. Now, I tried to do this by dividing, but the trouble is you end up with a number which you can't work with. Like divide it by 11, you end up with 191. Well, what is an 191 going to tell you? That tells you how many lines down in the program it is, but it doesn't tell you exactly where the data statement is. So you'd have to do another calculation. So it's easier just to subtract 11. It's only 191 long, so just if you subtract 11 each time, it divides it very quickly that way. And so I created this loop, which does that. Now, and then what I did next, the next step is to simply going to be a 0 to 11. So what we're going to do is we're going to subtract the argument from that. Now, that it subtracts the value that's going to be 11 or less from it. Now here what we're going to do is we're going to play the original crash sound we wanted to play anyway. This is like in the old program where we didn't have the music going on in the background. It just would have played this crash sound each time we hit another sprite. And then that's normal. Now what we had to add is this, which is compare 0 to A3CE. We want to see if that crash sound's done yet. So we're going to look for a 0 at the end. And it takes 1 second to play this, but GPL is a little bit faster than that. Not a great, it's not like assembly where it's instantaneous, but we're close to it. But what it's going to do is it's going to look for that 0 to see if the crash sound is finished. So it just runs through this loop looking for 0 on the sound list. When it gets to 0, it says, okay, it's done. Then it goes to the bottom line, which is down below. No, so keep looping. That's what I'm saying here. Okay. So then we go to the next section, which is down below, which is the I/O to the musad, which we did the calculations for. And by the way, it says above that double add 11 at musad. I'm going to go back to that in a second and show you. But I added that because we're going to skip past the sound that we were in because, as you can see, we interrupted a sound that was playing to put the crash sound in. So what we have to do is add 11 to the calculations we did to jump to the next sound because we couldn't finish it anyway because it'll cause a problem. Now, I do have some problems with one thing, and that is sometimes it'll play a sound in the background even though I've interrupted the sound. And I've not yet figured out why it's doing that. It shouldn't be doing that because I just interrupted the sound. It actually takes over. And I've even turned off the generators, all of them. And still, I'll hear a background sound in the background. And I don't know what's causing it because there's no reason for it to be playing anything. So if anybody can figure this out for me, that'd be great because I don't see why it's even doing it. It shouldn't. I've already taken everything into consideration from all the manuals that I'm doing. It's interrupting the sound and starting the next sound. I turned off all the generators, so it shouldn't be playing anything. And the next step that I took was to play the next sound and make sure it's done, and then go into that one. I suppose what I could do is I could make sure that it's ending the list, but there's no 00 at the end of the list in playing music, because if it did that, that would mean the list wouldn't be a list anymore. It would just stop. So the solution has to be something that is going on that I don't know. It does work. You don't hear the sound in the background because it's not very loud at all. But it sounds like it's turning on the last sound generator, even though I'm turning that off. Okay, let's go to the game and just show you what's going on here. This is just, the name's been changed. It's much harder to play the game now. I thought the game was much too easy and much too easy to track the balls. So now all the balls are going every different direction. They're much harder to track. So I added it to the timer to make it a little bit larger. Like I said, this is a GPL how-to, so if you want to modify this for your own, go ahead and have at it. Of course, we don't have the sounds here, so you can't hear the music playing in the background. You have to run the program to do that. So that's the entire demo. I think that you have something here you can work with if you want to modify it. You can even turn it into assembly. Most of the code here for doing this is pretty easy to follow and run. And have at it, guys. Have fun. Oh, I probably should add one more thing. You're not going to beat this game very easily. You're probably going to get your butt kicked trying to beat it. I made sure that this game is really tough to beat. So if you can get past all 6, go for it. If not, rewrite it. Later.